Okay.
Okay, so let's do a word problem. Yes. Okay, so what are the applications of derivatives?
For instance, like something that we're projecting
Right, so
marginal.
tangent line for just straight stuff. Tangent line, equation of the tangent line, where's the tangent line horizontal, that's one set. And then the word problem ones, which are marginal analysis, instantaneous change, projecting based on current trends. Right, those are based on derivatives too. So those are our two. We've already done a where is the function horizontal. I mean the tangent line horizontal. So now let's do a derivative. Word problem. All right, so the number of bicycle helmets people are willing to buy per week at a given price P is given by this. So number of bicycle helmets at price P is given this way. So X is the number of helmets, 1,000 minus 60 times the square root of P plus 25. Okay, so the first thing is to find dx dt. And the second thing then is, B, is to, when the price is $75, find the demand and the instantaneous rate of change of demand, and then interpret them. So when the price is at, find the demand and the instantaneous rate of change of demand. Instantaneous rate of change of demand. Okay, so let's start with part A. dx dp. So is this a basic? No. Is it a quotient? No. It's not one function times another. Times divided by another. Is it a product? No, because it's just multiplying by a number doesn't count as a product. So this is actually sort of almost a basic, except for this part. What do I know about this part?
You can't do square roots, we have to bring it up.
Right, well I need to put P plus 25 to the 1/2, and then this is, I have to use the chain rule because it's a composite function. It's not something, it's something to the 1/2, so that's my inside.
Right,
So-
outside is 60x.
Not 60x, so this would
Square
be,
root of x.
yes, right.
Or
So-
I guess square root of x.
So when I'm going through doing the derivative of 1,000 is 0. Minus 60 times, right, because subtracting and multiplying by a number just carries through, so I've got 0 minus 60 times derivative of this. So you guys do that one. That's a basic chain rule. Right, because I've got something to the 1/2. I don't know why that's coming.
Isn't that where they lock up the computers?
Maybe.
I guess sometimes you gotta make sure your laptop's not
Yeah.
overheating and charging.
Okay, so what do we have here? 1/2 times the something to the negative 1/2. And what's the derivative of the inside? Just 1. Derivative of P is just 1. Okay, let's clean this up. Negative 60 times 1/2, negative 30. I'm going to pop this back down into the denominator because we're getting ready to do some computation, and I always find it easier when I'm computing. I don't think of to the negative 1/2 very well, but I do think of square root. So negative 1/2 means that this would be in the denominator, and then I'm going to convert that to the 1/2 back to a square root. Does everyone see what I did? So I took the negative 1/2, the positive 1/2 in the denominator, and then anything to the positive 1/2 would be square root. Okay, so this is my derivative. So wow, wasn't this so much easier? That's kind of a cakewalk after the ones we just did. Okay, so when the price is 75, what is the demand, and what is the instantaneous rate of change of demand? So where do I find demand? From X. X is demand, so I need to put in 75 there. So 1,000 minus 60 times square root of 100. Did that on purpose. So 1,000 minus 60 times 10 minus 600, so 400. What are the units? Is it dollars?
Dollars per helmet.
Is it dollars?
Oh, price.
Demand is in number of helmets.
Right.
So be careful, you know, I know we want to slap dollars on things all the time, but it's not. This one is number of helmets, so 400 helmets.
At that price.
At this price, so at $75, that's the number of helmets I'm going to sell. What's the instantaneous rate of change of demand? Where do I find that? That's what the derivative is.
This is plug in 75.
So plug in 75 here. Right, so dxdp is negative 30 over square root of 100 minus 3. Minus 3 what's? If you're not sure, come back to here. X is in helmets, P is in dollars. Does that make sense? X is in helmets, P is in dollars. So this is, you're going to lose, your demand's going to go down 3 helmets for every dollar increase in price. So for every dollar you go down, you're going to lose 3. I mean, every dollar you increase the price, you're going to lose 3 helmet sales.
Now I want to know what the helmet costs.
Right here, $75.
Hey, we got it.
Right. So in this particular case, so
So.
does this make sense what we're doing? So the idea is you've got demand based on price. This is a composite, so it's a chain rule to solve it. But after that, everything else is the same. What is the demand at a price level? Plug it in. What's the instant rate of change? Plug it in. What does that mean? 400 helmets currently, but losing, we're at a point where we're going to lose sales, 3 helmets per dollar increase in price. That's the interpretation. So remember, the difference between find and interpret. Okay. So, oops, I have some things for people, homework. Stack and more, please turn it in. Let's see. These.
400.
Awesome, here's a reach. All right, Andre, here you go. Kevin, I have homework. Come over here, and Philip. Okay.
At least it's not on G-Town where it's just like a random, like, you know what I mean? Like next week you'd be like, we're learning a totally random.
So what I do in the class was go ahead and go through all the solutions online, go through and make sure that you solution. Anything that you want to ask me, I'm happy to chat with you about.
Okay.
Go ahead, this is good for now. Go ahead and get caught up with this. And it's kind of this section.
Okay.
So this is your problem set average, and this is how many points you got added. So you got this part out of the test, and then that many more points added from the minutes.
Okay, and you're here tomorrow from, is it 11 to 1?
12:30.
12:30.
12:30 to 1:45. But I can be here earlier than that, so just, you know, if you get earlier is better.
Okay.
Tuesdays I teach at 12:30, so that's I kind of have my office hours. Because if it's in class, I usually have them then, so I'll just use it. So if there's a better time for you, is earlier better?
It could be, yeah. How early would you be willing to?
Let me look. I don't remember. My schedule. So who else can do this? Let me just make sure I got it.
So I'd love to get some time
Yeah.
for some better understanding.
Awesome, yes. And then we have everybody here today. I think that's awesome. Okay, very excited. All right, so let me just check I don't, Tuesday. Does 12:30 work for you, or?
Yes. Yeah, I can do earlier than that too.
I've got something earlier than that, so 12:30
Yeah,
works for you?
12:30.
Okay, I'll come and see you.
Okay.
All right.
All right, I'll see you there. And
Okay.
it's Hamill, right? The math
Yes.
lab?
not the math lab, but panel 206. So it's the same,
206.
it's the same level as the library, so the library, if you go in the building that way, the library is this side, there's a hallway.
Yeah,
By the
yeah, same
bathrooms.
place we met for the
Oh, yeah,
makeup.
yeah, right.
Yeah. Okay, thank you.
Yep,
So
yes.
I forgot my folder that
Oh,
I
no.
have on my phone. Can I bring it